अकेले अकेले क्या पी रहे हैं सर? Milk with sugar? No, it's plain milk. No added sugar. Cow milk. बकरी का. तुम किसका पीते हो? बहुत सवाल पूछते हो. Don't expect too much. Otherwise, you will be the victim of मगरमच्छ. आज क्या पढ़ाएंगे सर? What is the topic of today? So आज का टॉपिक मेरे दूध का तरह ही है. Plain. Equation of plain. No added sugar, but still tasty and beautiful. Hello viewers, कैसे आप सब लोग? Hope you are doing well. So as we have promised in lecture number 19 that from the very next lecture, lecture number 20, we will start the concept of plane. So today we are going to find the equation of a plane in normal form. So without wasting any time, let's go to the blackboard. So first we will draw the diagram. First we will take x-axis, y-axis and z-axis. Then draw a diagram of plane. Okay, now name this. Say x-axis, this is y-axis, this is z-axis, this is the origin. Now first we will draw a perpendicular from the origin to the plane and name this point, which is the foot of the perpendicular, as n. So let us consider this as n vector. Okay, and now also let us consider any point P on the same plane and let us consider its position vector as r vector. Now this point n is the foot of the perpendicular drawn from the origin to the plane. So this n always lies on the plane. Also the point P lies on the plane. So if we will join this point. So this is say NP vector. So NP vector lies on this plane. And when vector is perpendicular drawn from the origin to the plane. So when vector is perpendicular to NP vector. It's very simple. We will understand this concept again through some models. So take this tripod. Please take your leg apart a little bit more so that it is easy for me. Okay, thank you. So now consider this as x-axis, this is y-axis, this is z-axis of this gorilla tripod. Now consider this as the plane. Take this book as plane, okay, like in the diagram. So if we consider this as origin, so if this is the plane, okay, so then this is say the n vector, that is the perpendicular drawn from the origin to the plane. So this is the point n. So n is the foot of the perpendicular. See, foot of the perpendicular, because I am mentioning this term foot of the perpendicular because it is a very important term which we will use while solving some important type of problems in future. So remember this term foot of the perpendicular, it will be used. So now this is the n vector. Let its magnitude be d and let n cap be the unit vector along this n vector. We will just write this in blackboard also. You just understand this now in this model. So this is n vector is perpendicular to this plane. Now we have taken another point P. Say this is the point P on the plane. So this is OP vector. So OP vector, and we have also considered n vector. So if the point P lies here and the point N lies here. So NP vector lies, this NP vector lies in this plane and ON vector is perpendicular to the plane. So by the concept of vector chapter, we are using the concept of dot product. As the two vectors NP vector and ON vector are perpendicular to each other. So ON vector and NP vector equal to 0. That is the key concept of this theory. If you understand this concept by this model, then you can write the proof of your own. So now we are going to prove the theory in detail. So if you want to listen the proof in detail, then you can listen, otherwise you can skip to the problem directly if you understood already. Thank you. So now we are going to give the proof in detail. So we are going to the blackboard. So let's take white color. Okay. Let us consider that the perpendicular distance from the origin to the plane is d. Also, let n be the foot of the perpendicular drawn from origin to the plane. Therefore, ON vector is perpendicular to the plane. Also, let n cap be the unit vector. Unit vector along ON vector. Therefore, ON vector is what? ON vector equal to d n cap. Magnitude plus direction makes it a vector. Simple. So now we are going to the next page. Now P be any point on the plane whose position vector is r vector, say. Let r vector equal to x I cap, y j cap plus z k cap. That is x, y, z are the components of r vector. Now as P be a point on the plane and n also be a point on the plane, so NP vector lies on the plane as we have discussed in the model. Therefore, NP vector lies on the plane as both n comma p points, n comma p points, undo both points n comma p lies on same plane. Very simple. Now NP vector lies on the plane and ON vector is perpendicular to the plane, but as ON vector is perpendicular to the plane, therefore ON vector or NP vector dot ON vector equal to 0. See previous page. ON vector dot NP vector equal to 0. Now here we are going to use the concept of triangular law of vectorization. From here, from this triangle, from triangle ONP, we have ON vector plus NP vector equal to OP vector by triangle law of vectorization. Triangle law of vectorization. So, NP vector means what? NP vector means OP vector minus 1 vector. And therefore, NP but NP vector equal to OP vector minus 1 vector. See from this previous page. NP vector, OP vector minus 1 vector. But OP vector means what? OP vector means R vector. Minus 1 vector means already we have written D n cap. So therefore, from here we can write that NP vector, we just simply put the value of NP vector here. NP vector means R vector minus D n cap dot 1 vector means again D n cap equal to 0. But as D is the distance from the plane to the origin, so D must be not equal to 0. But as D not equal to 0, so we can divide by D both sides. So we get R vector. So by, you can go to the next page. So by dividing both sides of the relation by D, we have previous page R vector minus D n cap dot n cap. R vector minus D n cap R vector minus D n cap dot n cap equal to 0. So from here R vector dot n cap minus D n cap dot n cap equal to 0. But as n vector is a unit vector normal to the plane, but first it is a unit vector, but n cap magnitude equal to 1 as it is a unit vector. So implies R vector dot n cap equal to D. But here I have to write but n cap magnitude equal to 1. So therefore n cap dot n cap equal to n cap magnitude cos 0. So magnitude squared equal to 1 squared equal to 1. For your convenience, I have broken down the steps. Okay, it is a is 1 square. Okay, so we are done. We have derived the vector equation, that is equation number 1. This is 1 is the vector equation of the plane. In which form? In normal form. Done. But we have to find the equation of the plane in Cartesian form also, because in problems we have to use the vector form and Cartesian form accordingly and wisely. Okay, so next page, the Cartesian form. So vector form is R vector dot n cap equal to D, where R vector equal to, we have written earlier also, xi cap y j cap plus z k cap, where R vector is nothing but the position vector of a arbitrary point P on the plane. And what is n cap? N cap, we know n cap equal to a unit vector normal to the given plane. So equal to, say, L I cap, laser, undo, okay, M J cap plus N K cap, where L M N are what? L M N are direction cosines of n cap. So we just simply put the value x I cap plus y j cap plus z k cap dot L I cap plus n j cap plus n k cap equal to d, equal to implies Lx plus my plus nz equal to d. So this is correct. This is the equation 2. So 2 is the equation of the plane in Cartesian form. So we are done. So now we will see another note of this theory. Go to the next page. Previous page. Okay, next page. Okay. So 2 is the Cartesian equation of the plane in normal form. Now note, if instead of unit vector, if n vector will be the normal vector to the plane, then what will be the equation of the plane? If n vector be the normal vector to the plane. Previously we have considered unit vector normal to the plane, but here we are considering a normal vector to the plane, not a unit vector. So here the components are the direction ratios we are considering. If n vector is the normal vector to the plane with direction ratios A, B, C, then n vector equal to what? A I cap plus B j cap plus C k cap. Then the equation of the form is, then equation of the plane in normal form, and in normal form is r vector dot n vector equal to d. D is nothing but the distance of the plane from the origin. So equal to, it will take the form x I cap plus y j cap plus z k cap dot a I cap plus b j cap plus c k cap equal to d, implies ax plus by plus cz equal to d. This will also be very useful while solving problems. So now we are going to see one application of this theory. So example, find the vector equation of the plane which is at a distance of 6 by root over 29 unit from the origin, and its normal vector from the origin is this. So here observe that it is normal vector, not a unit normal vector. So it is normal vector from the origin, this. So solution. take this white. Okay. So now normal vector from origin to the plane is 2I cap minus 3j cap plus 4k cap. So we are going to find the unit normal vector. So to find the unit normal vector, we are going to divide this by its magnitude. Therefore, the unit vector, this is n vector. Therefore, the unit normal vector n cap is n vector by n vector magnitude. Simple. We are using the concept of vector chapter. So to understand all the concepts of theorems on geometry, first you have to learn the concepts of vector chapter. Then you come to this chapter. It will be very easy to understand. Yes, sir. So 2I cap minus 3j cap plus 4k cap. So what is the magnitude? We just derive here the rough 4 plus 9 plus 16. So 16 plus 20, 29. So 2 by root over 29 I cap minus 3 by root over 29 j cap plus 4 by root over 29 k cap. So therefore we have derived n cap. So therefore the equation, next page. So equation, vector equation of the plane is r vector dot n cap equal d. So r vector dot n cap means what? See previous page. 2 by root over 29 I cap. 2 by root over 29 I cap. Previous page. Minus 3 by root over 29. Minus 3 by root over 29 j cap plus 4 by root over 29 k cap equal to d means what? It is given 6 by root over 29. So answer. So in today's lecture number 20, we have proved one theory and also see a application of the theory. Hope you have enjoyed today's lecture. Thank you for watching.